Hi and welcome back to our channel. In today's video, we'll be discussing secure over the air updates, that is OTA. We'll explore both the advantages of OTA in vehicle systems and disadvantages of not having an OTA in vehicle systems. We'll also see how they are integrated into modern vehicles and examine some real world use cases. This video will definitely help you understand the importance of this technology and how it's shaping the future of automotive security. So let's get started. We'll be having two speakers in this video, which is Ronak and Dharmesh, who will be taking us through the slides and explaining the topic in detail.
Yeah, so let's start with some history about cars. As we have shown here, in the beginning, the car were all the mechanical components and no electronics or electronic components. And now, uh, with the evolution, all the cars have many issues. So in the latest car, there might be 70, 80, 100 issues, and with so many software and so on. So now, uh, if there is a software in the car, they needs to be maintained and updated. And that is what we'll explore with the OTA. So over there update means the software in all the issues of the car can be updated remotely. So all the software are getting downloaded remotely, just like how maybe your mobile applications or the mobile software gets updated. So everything are getting downloaded from internet and it is installed, and then car software is getting updated. So this is basically OTA in simplified terms. So let's look into the disadvantages if we don't have the OTA in the car. So first point is about high cost in case of recall. So in the development of these complex issues and software, there might be some major bugs coming up when the vehicle is on the road. And then to fix those bugs, uh, we have to update the software, and to install those new software, we need to recall the car, and in the service stations, the software has to be updated when there is no OTA. So this could uh, be very cost consuming. Second point is about time consumption. Again, to update all the issue software in the car in the service station, it might need so much of time. So it is time consuming process, and also it is causes inconvenience to the car owner because the car owner has to bring the car to the service station and so on. And the last part is about the coverage. So now any particular car can be sold in any country in the world. So now if we have to update the any particular car software in complete world, that is like very complex task. So the coverage is like then each and every vehicle owner has to go to the service station in all the places and they have to get their car updated. So when we talk about the service station, then the coverage is less because everyone has to go by manually, right? Go themselves. So these are all the disadvantages what we think of without OTA.
Well, I mean, to add on to what Ronak has mentioned, I mean, having said that, there is a lot of attention on automotive cybersecurity. Over there, update makes a lot of sense because even in the case of some cybersecurity vulnerabilities or incidents, the update has to be shipped very fast, right? So this is where there may not be enough time to, wait for a car owner to go to a garage or a service station or a workshop to update the software. So that may not work. So this is where, of course, even before ISO 21434 was introduced, there was OTA features in some of the ECUs. But I think after the, let's say release of 21434, there has been a lot more focus on over-the-air update, because going forward, what could be the, let's say, severity of cybersecurity incidents which nobody know, right? It could be in a large scale. So this is where I think over-the-air update makes a lot of sense, and without having such kind of a feature, will lead to a lot of inconvenience both for the OEMs and also for the end customer.
Okay, so let's have a look into the advantages of using software over the air update. So here, yeah, it is all the opposite of the disadvantage. So first point is about immediate fix in case of software bugs. So OEMs can provide software bugs immediately. Yeah, if the OTA is present. And next point is about again saving the time and money, as we don't have to recall all the cars, and service stations will not come into picture, and we also don't have to, I mean, the car owner, we don't have to drive to the service station and so on. So it saves time and money at the both the end. And third point is about large coverage. So as I told, like the software update can be downloaded via the internet, so it can be downloaded to all the cars at once if required. So it provides large coverage. And yeah, fourth point is about customer satisfaction. So again, if the bug fix are getting solved or the software keep getting updated, so customer is satisfied. And the last point about is the new model or the new business model. So again, it is like app. So when you can keep getting new apps in your mobile, you can also pay for them and use them, right? So this also provides new business possibility, like you can use different features in your car based on the payment basis and so on. So this all are could be the advantages of over the air updates.
Hmm. I mean, since we are talking about the advantages, maybe a question to Falgun. So, Falgun, if you look at the advantages which are listed here, these are more from the business perspective or from the customer service perspective. So, if you think about automotive cybersecurity, what do you think could be, an advantage of OTA in issues very specific to automotive cybersecurity and its compliance, let's say?
Yeah, so that's a good point. So I still feel one of the point that is mentioned here is still applicable to the cybersecurity. So like for example, immediate help for the car owners and also save money and time. So these 2 points, of course, we are talking about both manufacturers and car owners. Now, whenever there is a cyber incident that happens, the most important thing is to rectify, because if we don't rectify, then there is a continuous damage that can happen, right? So let's say one car is broken down because of a cyber incident. The architecture will pretty much remain the same for all the variants of that car, which means there are millions of such cars out in the world. And this attack can happen to many of that car, many of those cars, many of, I mean, the millions of those cars. So the frequency in which, or the time in which the OEM or the suppliers, the tier ones, whoever is the affected party in terms of the development, if they are able to fix and provide the fix, of course, validate, verify, and then provide the fix immediately as soon as possible, further attacks can be mitigated. There are also some attacks where you get as a first step some access, and then the second and third step you will actually get the data or the required information out. So OTA prevents the second and third step also, or rather OTA helps you to prevent the second and third step if you can ship out the software, maybe change the signature, or provide some basic firewalls, whatever is the mechanism based on the incident that has happened. So if you can install that, uh, it can majorly mitigate, theft of information, thereby consequently, or rather subsequently, helping future lawsuits or the financial losses for both vehicle owners, vehicle manufacturers, and the suppliers. So this is another big advantage of having over-the-air update in the whole cybersecurity environment. And this is also one of the reason where we have the UNEC R156, which is about the software update management system, SUMS, which European Union is also making it mandatory to have this software update over there updates for all the vehicles that is being put on road since 2024 July.
So yeah, we have seen advantages of over there update. Now, as I explained, this complete process involves different components and also like some of the internet and like those components which are highly possible to be attacked. So that is where we have to secure our software over there update. And in coming slides, we'll have a look how secure software over there update can be implemented.
Yeah, many thanks, Ronak, for explaining about the need for software over the air update in automotive. Also, thanks to Falcon and Praveen to give their opinion or clarifying a few points on the over the air update. The question now become how we can implement this or what sort of architecture we need. The short answer to that is we need backend infrastructure to support sending out the software updates. We also need to make some modification to the vehicle and particular issues in order to enable these software updates to work. Now look at the backend and vehicle architecture for supporting such software management system. So in particular, there are three main areas we need to discuss. First one being the update criteria, update creation. Other is OTA backend, and third one is OTA enabled vehicle. So the first criteria, the update creation can come from newly developed feature or generally through the maintenance or bug fixes. So once this updates is generated, it's being sent to the OTA backend system where particularly it will be sent to the update manager in the backend. The update manager communicates it with the database to create the finalized update that being sent to the vehicle. So this update then sent to the central control unit of the backend system, whose task is basically to communicate or send this update to the internet via the cloud to the vehicle. And the right hand side, you can see it in figure, is the third step where this update will be downloaded to the vehicle on the gateway issue, and it's depend on the architecture or from the OEM specification how they would like to implement this. So either gateway will be responsible to update this newly received software to the particular issues, or it will be the responsibility of the issue, whichever update they received from the gateway, it will be flashed into that particular issue. So here you can see in the architecture, due to the complexity of the system and number of moving parts across the system, we can see that there could be many attack surfaces where attacker can modify the update or dig into the system. Let's see some of the attack surfaces. So these are the attack surfaces. You can see it in a red mark here, which is possible where attack can happen. So attacker will try to exploit this and modify the software update. One example is that attacker can try modify the update as soon as it is leaving or while still on the central control unit of the backend system. Therefore, the backend needs to be secured through some typical IT security measures. Conversely, the attacker can also try to attack when the software is updating happening on the car itself. And this case is little more difficult to defend against since the attacker has the physical access of the car, or let's say the embedded devices. In short, this means that we need to ensure the authenticity and integrity of the update all the times. Optionally, we can also secure the confidentiality of the update by providing some secure mechanism for encryption on the updates. We can secure the confidentiality of the update. But important things for securing the update process, we need to secure the authenticity and integrity of the update. In the next slide, we will discuss how we can achieve these security goals both within the backend infrastructure as well as on the vehicle side.
Okay. So, Falgun, maybe I have a question here because it's an interesting image which shows us the backend, OTA backend, and also OTA enabled vehicles, which more or less the issues in the vehicle where your software updates will be deployed, right? Now, when it comes to cybersecurity, there are two terms which are often kind of not well understood. One is automotive cybersecurity. There's always a confusion, with the people or the experts who are working on it. What is the scope of automotive cybersecurity? Then comes your IT cybersecurity, which is more like applying, applicable to the organizations or the systems and so on, which is kind of an outside the vehicle. Now, keeping this particular diagram, in front of us, where do you think the scope of automotive cybersecurity will come into, and what do you think fall in the scope of IT cybersecurity, let's say, and also why?
Good. That's a very interesting question. The reason I say an interesting question is a clear demarcation between, assigning the IT cybersecurity and the automotive cybersecurity is a bit difficult. It's clear that whenever we talk about OTA enabled vehicle, it would be automotive cybersecurity. The reason why I say it is automotive cybersecurity is because we are considering a live scenario. That means things are developed, it is delivered to the customer, end user has the car, and OTA is functional. In that scenario, automotive cybersecurity is applicable to the OTA enabled vehicles. If we are considering the development stage for the OTA enabled vehicles, even your IT security comes into picture. Now, why do I say IT security comes into picture? Because whenever you are doing the OTA updates, right, over the air software updates, you send many packages. You need to have multiple authentication mechanisms. You need to have some kind of signature, some kind of verification that you are getting the data from the trusted source. You need to ensure that the updates are happening in the right way. So these are some of the things for which you need some certain keys, right? So you need some public keys or private keys depending on whatever mechanisms you're going to use for securing your over the air update. All these things during your development environment is visible to all your developers, and also in your development environment it may be open to some kind of attacks as well there. Like for example, these days we are doing a hybrid environment in terms of development. We are working from home or we are working from remote and office. So if you are working from remote, which means you have the option to probably work from a cafe too. And if you are a developer, you are trying to code that piece of software from a cafe, somebody can just over your shoulder have look at all these keys, right? So this is where the IT security comes into picture, where certain rules and regulations must be established in the organization. So this is about the OTA enabled vehicles. When we come to the OTA backend, even if it is live update, that means everything is functional. I would say both IT security and automotive cyber security is important. Majority goes to IT security because you need to have a clear setup defined in your backend. That means you need to have right infrastructure, you need to have protections in of the environment, whatever is the location. So have locks enabled, access controlled, entry to such facilities. So these things fall under the IT security. But what comes on the um, automotive cybersecurity part? So there are different update managers. You see the update managers, there is central control unit, there is update database. So, and these things are, I mean, they receive the new software packages either with a new feature or maintenance or bug feature. So there is a separate channel over there, right? So you have the update creation channel. So it can come through various channels. So there can be scenarios where a hacker also can put his or her packet of data, or a new feature or a bug fix piece of code as a bug fix piece of code into these databases, right? So this is where whenever you receive a new piece of data or maintenance software or a bug fix software, you need to have mechanisms to verify it is coming from trusted source, it is encrypted, and it has the right authentication, it has the right permissions, etc. So this is where the cyber security also comes into picture. This is my take on how we differentiate probably IT security and automotive cybersecurity in the whole of OTA process.
So thanks, Falgun, for explaining about the IT security and automotive cybersecurity in OTA, where it's mostly used. Now let's see how to achieve these security goals uh, and mitigate this, whichever the attack surfaces we see it here on the screen now. So here we can see where we would like to integrate some of our security solutions in order to prevent that attacker would not gain the access. Even if he gains, there is no damage is done. So you can see it in the dark clay color here uh, at the backend system as well as at the OTA enabled vehicle. So the first measure is to implement a security manager and security database in the backend system. What this allows to do is to generate the signature over the each update packages or the entire software update. What this also means that whatever the data or update along with this certificate will be sent to central control unit, and then the central control unit also would be responsible to additionally give some signature or add some paddings for on the update to make it more secure. And also the central control unit is now responsible while sending out this data over the internet. It would use the secure TLS connection. So as we discussed in our last video, more detailed about the TLS. So if you anyone would like to see more in detail how TLS works, we explained in last video. So please visit our last session. Uh, Same. So on the right hand side, also when the software updates is being downloaded at the vehicle level, the gateway issue will make sure that it is downloaded through the secure TLS connection. So we have the secure channel while downloading the software updates. Also, once it is downloaded, still there will be some attack surfaces within the vehicle itself. So that's where we have secure flashing mechanism, uh, which uses the secure hardware. Same thing. Some security measures will also be available at the issue level in case attacker can gain access at the issue level itself. So by integrating the security measures, we can prevent these attack surfaces and make this normal OTA to more secured way. So secure the over there update. So now let's see how all this process will detail in detail works in our next slide. So in this slide, as an example, you can see on the left side, the previous slide, we have backend system where security manager, central control server is there. We have TLS secure channel while transferring the data. So on the right hand side, you see the gateway where the full software package will arrive, and the gateway will verify the software package. Then, based on corresponding issue, it will send this package to corresponding issue, and issue will verify again the software.
Yeah, so just to add on, so ECU will verify the individual software which is or the firmware which is relevant for the ECU. Gateway, since it is connected to multiple ECUs, so there would be one ECU in the complete vehicle which will have it's more like a single point of contact in the vehicle to the backend system, because if you end up having multiple points of contact, then it would the whole thing would become very tedious and chaotic. So this is where gateway becomes a single point of contact where it receives a bigger chunk of packages if there are multiple updates, let's say, and that the verification of what data comes to the gateway itself, the whole package, the verification is the responsibility of the gateway, and then gateway then decides, okay, the smaller chunk, if there are multiple ECUs, there is as shown in the figure, there is light delta installer when in maybe, I don't know, door ECU, there may be uh, gearbox ECU or maybe HMI. So there will be multiple ECUs for which each individual smaller packages will be sent out, and they will also be responsible, because you need to, again, we come back to our original topic where we started, multi-layer security. So this is where another layer of security is added at the ECU level, where you also verify the signature and the authenticity of that particular package.
Yeah, thanks for explaining the more in detail. Now let's see what are the steps involved in this whole process. So as we mentioned, so there are two options. Uh, while generating the package, it can generate the whole software update and send it over the air. The other option is it will just generate the delta packages. Delta packages are nothing but the only modified the software code which will be sent to the over the air to the vehicle. Now this is effective part because it will have less data and the traffic over there will be less. So we are considering the use case here where we are generating the delta packages. That is the first step. The second step here is once the data packages are generated, then it needs to be signed. This delta packages. So security manager will sign these delta packages, and then this will be sent as a software update to the central control unit. Now the central control unit will run the software manager campaign, and it will send out these packages one by one to the gateway issue. So once the data or software package, delta package is getting downloaded at the gateway issue side, it will first validate of the received delta packages. Uh, so here first, this is iterative process as I mentioned in the screen. Uh, each packet will be verified and until the last package is arrived. So next step, once it validated all the packages are correct, then it will unpack and then identify for which particular issues this software is belong. Also, what would be the current version, and those information will be unpacked by the gateway. On the next step, since the gateway here is responsible to flash this software at the issue level, it will enable the particular issue, unlock that issue for the software flashing. And the last step here is whatever the software it needs to be uh, installed at the issue level, it will be updated. This firmware will be updated by the issue. So these are the steps in detail. Now let's see some of the use cases for the secure over the air update. So first use case is where successful software update is happening. So you can see all the four steps on the right hand side vehicle side are successfully executed, and there is no error in any of the steps, and the updates are happened successfully. The second use case, what could be possible is, let's say, while transferring data from the backend system to the vehicle, uh, attacker can tamper this delta package during the transmission itself. Then, while verifying the signature or certificate at the gateway level, uh, it will see that it will not match this certificate or due to the modification, and this process will stop here and it will not continue. So this is the second use case. But as we discussed in our previous slides, so there are many attack surfaces available. So it could be that if attacker have the access within the vehicle, even we get the update at the gateway level while transmitting from gateway to the issue, there could be attack possible. Also at the issue level itself, while updating the package to the issue, there also attacker can modify. So for this we have different security mechanism, and that's why we have layered architecture. So to prevent everything, we should implement those security feature in order to avoid the attack or reduce the attack surfaces for the attacker. So this is the overall understanding what we discussed regarding the secure over the air update. So yeah, if anyone have any question, we can discuss.
Maybe a small question. What is the reason it's called Delta package? Is there a meaning
Uh,
for that?
yeah, Delta package, as I mentioned, it's just the modification of the code where it
Delta
let's say
change. Okay.
delta change, yeah,
Okay.
not the entire software.
Since we have discussed about the advantages and disadvantages, so let's get to know some risks. So I just wanted to know how might issues such as incomplete installation or software incompatibilities impact the overall performance and safety of the vehicles?
Okay, so if I may answer your question regarding the risk. So yes, during the secure software update or firmware over the update process, we have risk involved in that. So if let's say in between the transfer, the package gets corrupted. Also, if there is some problem, then what will happen? If the older version is corrupted, then the functions of the issue will not work properly. So for this, to mitigate this type of risk, the firmware over air update also have some mechanism called the rollback mechanism, where it will be having separate memory. So older version will be first stored there. Then once the newer firmware is updated, it will just initialize and check all the things are working correctly. If it doesn't work correctly, then it will again shift to the older version, since it was on the other memory location, and this is how it will be avoided. So yeah, there are some risks are present currently, but we also have mitigations for that, or within the when implementing this feature, this will be taken care.
So just to add on to what Dharmesh mentioned, so rollback feature is, or rather a sub feature, is a very important topic, because whenever you decide to perform OTA, whenever, so the whole process starts from the UNEC regulations, right? So UNEC R156 mandates you to have OTA. Now, you can't randomly just have OTA, because if you have OTA, there are so many risks, as Bhumika rightly asked that question. So this is where, whenever you're considering OTA feature, rollback should also be considered. Now, what is the consequence that you will get with rollback? Typically, the biggest problem in automotive industry when we are talking about ECUs is memory, right? You don't have enough memory. You want to keep everything small. For rollback, you need to allocate a mirror memory. What is a mirror memory? Mirror memory is where you keep a copy of your firmware, so that if certain things goes wrong in the existing firmware, you have a mirror memory where you can swap the existing firmware, which is clean and not corrupt, so that your ECU is back up again. So this must be considered, which means when you want to have a mirror memory, you need to consider this in your whole not just software architecture, but at the system architecture level, because these are some of the things which are also handled by your hardware. So whenever you are considering OTA, system architecture, hardware architecture, and software architecture plays a key role, uh, provided that you are newly implementing the OTA use cases. So there are a lot of changes that would require in your design itself, and it is very good to consider all these things in the design phase rather than at the last, maybe implementation and testing phase, where you have to go back and update your hardware, which will be much more financially disadvantageous, and of course time wise also disadvantageous.
So, are there options for users to decline or opt out of receiving OTA updates? And if so, how can they exercise this option?
So to answer your question, in theoretical, this is possible. It's depend on the manufacturer or service provider where they will provide this update. If it is less critical or convenient update, then this could be the optional one. But some security relevant feature where the fix is there and really it needs to be implemented, then those are, updates will be the mandatory one for users.
So, thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on automotive security and technology. Feel free to leave your thoughts or questions in the comment section below. We love to hear from you. Until next time, have a nice time.